So the reason on the y-axis symmetry that we replace the x and not the y, what does it mean for something to be symmetric? Identical on both sides. So if it has y-axis symmetry, that means if I have my graph in front of me on a piece of graph paper, I can take it and I can fold it on the y-axis, and those two sides would match up perfectly, right? So if I fold it in half on the y-axis, I take everything that was on the positive x side and I lay it on top of everything that's on the negative x side. So the positive x's and the negative x's would have the exact same output. Same thing is true when we're talking about x-axis symmetry. Now I'd be taking a graph like this and folding it in half like this, like top down on top of the bottom. And if I do that, I would take the positive y's and I would lay them on top of the negative y's and they would match up exactly. Symmetry about the origin is rotational symmetry. So the one that I think about with this is like a circle. If the center is at the origin, if I take that circle that's around the origin and I spin it, you're not going to be able to tell a difference in that graph. That is symmetry about the origin. Do you guys still need a couple minutes to write this down? Okay. Absolutely. We're going to use these in tests. We'll do the first several together. And then I'll let you guys practice a couple on your own. And then we'll talk about them and I'll work through any of the on your own ones that you need me to explain further. You guys okay to move forward with some examples now? Okay. So we want to determine the type of symmetry for each of these. So we're going to use the tests. I like to do my y-axis symmetry first. You can do them in whatever order you want to. So for y-axis symmetry, what value do I replace? The x, and I replace it with a negative x. So it was an x equals, now it becomes a negative x equals. And then I'm going to make this look as much like the first equation as possible, and if it comes out to be exactly the same, then I know it has y-axis symmetry. So previously it was x equals, so I want to make this one an x equals. Right now it's negative x equals. How do I get rid of that negative out in front? Divide both sides by negative 1. So I get x equals what?
2y squared.
2y squared. Is that exactly the same as what we had before? No. So it does not have y-axis symmetry. Then we go to check for x-axis symmetry. With x-axis symmetry, which piece do I replace? The y. So I have x equals -2, and anytime I make a substitution here, if there's stuff happening to that variable, I'm going to put it inside parentheses. Just like when I substitute any other number in there, I'm going to put it inside parentheses. -y squared. That means -y times -y. How would that simplify? Y squared, right? -y times another -y. The negatives are going to cancel, and so then I'm just left with y times y. So this is x equals -2 y squared. Is that exactly the same as what I had before? Mm-hmm. Then that means this has x-axis symmetry. We still need to check it for symmetry about the origin. So checking it for symmetry about the origin, what do I replace? X and y. So I'm going to have -x equals -2, and then inside parentheses, -y squared. Well, we just talked up here, when I take -y and I square it, that's going to come out to be a positive y squared, right? So I would have -x equals -2 y squared, and then I divide both sides by -1, and I get what? Yeah, x equals 2y squared. Which is not the same as what I started off with. So this is not symmetric about the origin. We only had x-axis symmetry. It is possible for an equation to have no symmetry. Lines, if you think of drawing a line, almost all lines, if you fold it on the y-axis, it's not going to match up. If you fold it on the x-axis, it's not going to match up. If you rotate it around the origin, it's not going to match up. It's possible for these equations to have more than one type of symmetry. That's why we do all three checks. So let's look at this next equation. Y equals 1/4 x cubed. Let's do our check for y-axis symmetry first. So I replace the x with a -x. Inside parentheses. If I take something that's negative and cube it, it's a negative result. So I would have y equals 1/4 times -x cubed, which would simplify to what? -1/4 x cubed, yes. Y equals -1/4 x cubed. Is that what we started with? No. So this does not have y-axis symmetry. So then we check for x-axis symmetry. So I'm going to replace the y with a -y this time. Y is equal to 1/4 x cubed, -y. So I'm going to divide both sides by -1. And I get, once again, y is -1/4 x cubed, which is not what I was looking for. So then we will check this for symmetry about the origin. I'm going to replace the x and the y this time. So -y equals 1/4 And then inside my parentheses, negative x, and I'm going to cube it. When I cube something that's negative, it stays a negative, right? So this is going to simplify to be negative 1/4 x cubed. And then I'm going to divide both sides by negative 1. And what happens? I get a positive 1/4 x cubed. Is that what I started with? Yes. So this is symmetric about the origin. Make that all just a little bit smaller so we can see it. Let's do one more of these together, and then I'm going to have you guys do a couple on your own just to practice. There's nothing special, by the way, about the fact that these are x equals or y equals equations. If I had the equation of something that was in standard form, it doesn't have to be x equals or y equals. I can take the negative x and the negative y and substitute them in any form. All right, so y-axis symmetry first. So I'm going to replace my x's. So I have y equals negative 3. I replace this with a negative x, and I square it, plus 4. When I square anything negative, it becomes a positive. So I would have negative 3x squared plus 4. Do we have y-axis symmetry? Yes. And then I want to check for x-axis symmetry. So now I'm going to replace the y with a negative y. So negative y equals negative 3x squared plus 4. I divide everybody by negative y. Or, sorry, not negative y, negative 1. What am I doing? Y equals what? 3x squared minus 4. Is that what we started with? No. Nope. So we do not have x-axis symmetry. And last but not least, we're going to check for origin symmetry. So I'm going to replace both the x and the y here.
Thank you.
So I have negative y equals negative 3, and then negative x squared plus 4 exponents first. So negative y equals negative 3x squared plus 4. I divide everybody by negative 1. And I get y equals 3x squared minus 4. Do we have origin symmetry? No. All right. I'm going to give you guys 3 examples that I want you to do on your own. Check them for all 3 types of symmetry. Before I set you loose, does anybody have any questions? Okay. Take a couple minutes to work on these 3 right here. If you guys are ready, we'll go through these, but I don't want to cut anybody off if anybody's still working. All right. D. Does D have y-axis symmetry? No. Oops. Does it have x-axis symmetry? Does it have origin symmetry? Yes. E. Do we have y-axis symmetry? Yes. Do we have x-axis symmetry? Yes. Is it symmetric about the origin? Yes. We have all three types of symmetry. This one, by the way, and we'll study more about this probably tomorrow. This is the equation of a circle. The center of this circle is at 0, 0, and that's why it has all three kinds of symmetry. Because if I take a circle where the center is the origin and I fold it over the y-axis, those two halves match up. If I fold it over the x-axis, those two halves match up. And if I rotate it, that matches up all the way around. What about on F? Do we have y-axis symmetry? No. X-axis symmetry? Origin symmetry? Yes. Do you guys want or need to see any of these three? Yes, sir.
Can you go over D, the origin?
Absolutely. So on D with the origin symmetry, remember we're going to replace both the y and anywhere we see an x with a negative. So I'm going to have negative y equals 5 and then negative x cubed plus negative x. So the first thing I would do is simplify things over there on the right-hand side. I would have negative y equals, this is going to be negative 5x cubed. And when I add a negative, that's minus x. And then because of the y, we divide everybody by negative 1, and that sends me right back to a positive 5x cubed plus x. Does that make sense? Cool. Did you forget one of the substitutions?
The x on the end.
Yeah, that'll change it. Anywhere you see an x, you replace it with a negative. Anywhere you see a y, you replace it with a negative, even if it shows up more than once. Do you guys have any other questions about this? Yes, ma'am.
Can you do F for the origin symmetry?
Absolutely. On the origin symmetry there, I'm going to replace my y with negative y. I'm going to replace my x with negative x, and that's to the 5th power all over 2. When I take something to an odd power, will a negative change to a positive or will it stay a negative?
Negative.
It's going to stay a negative. Because anytime I multiply two of the same thing together, it's going to come out positive. Here I do that once, twice, and then the last time I just multiply by one of those. So I would have a negative x to the 5th up here over 2. And then I'm going to divide by negative 1. I already have a fraction. Can somebody tell me something that had the exact same effect of dividing by a negative 1?
Multiply 1 by negative 1/2? No, 1/2.
I can just multiply by negative 1, right?
Oh, yeah.
That's okay. I don't think I was speaking clearly enough there. So I'll totally take the ownership for that. If I multiply by a negative 1, it's the same thing as if I divide by a negative 1, right? Same exact effect. So that'll cancel my negative out here. And I only have a negative here. Negative times a negative will give me that positive that I'm looking for. So I would have x to the 5th over 2. Because remember, when we multiply fractions together, we always put it over 1, and then you multiply your numerators together and multiply your denominators. So that's why the 2 doesn't become a negative, but my numerator becomes a positive.
Okay.
Make sense?
I forgot my exponent.
Got it. Any other questions here? Cool. Let's go and talk about finding your x and y-intercepts. An x-intercept, this is anywhere the graph touches or crosses the x-axis. X-intercepts are going to have wherever it touches the x-axis first, but the second part of the ordered pair will always be what? 0. So if I want to find my x-intercepts, we're going to let y equal 0, because that's always going to be the y part of that ordered pair. And then we'll solve for x. If an x-intercept is anywhere the graph touches or crosses the x-axis, what's a y-intercept?
Or y-axis.
Yes, anywhere the graph touches or crosses the y-axis. Ordered pairs for y-intercepts. Which part is always the same?
X.
The x part is always
0.
a 0. So when I said that about the x-intercepts, I said, okay, so we're going to let the y equal 0, because the y part of the ordered pair is always 0 in an x-intercept, and then I'm going to solve for x. How would I find a y-intercept then?
X equals 0.
Yep. We're going to let x equal 0, and then we're going to solve for y. Let's practice finding a couple. You guys okay if I switch the screen?
Yeah.
Okay. Tommy, you with me? You doing all right? Okay. So on the first one, I want to find the x-intercepts and the y-intercepts. Let's find x first. What do I set equal to 0 if I want to find an x-intercept?
Y.
Yeah. Let y equal 0. So I'm going to put 0 in the place of the y equals x squared plus 8x plus 7. This is a quadratic equation, right? It's equal to 0. Quadratic equations need to be equal to 0. And then what can I do with them? I can factor them. What multiplies to 7 but adds to 8? 7 and 1. So this would be x plus 7, x plus 1. So what are the solutions for x then? Yes, -7, -1. Then I would put them in the ordered pairs. So that would be -7, 0, and -1, 0. Because remember, what do we always do with our factors to find the solutions? Set them equal to 0 and solve for x. All right, so there's my x-intercepts. I had more than one of those. For my y-intercept, I let what be 0? Let x equal 0. I like this one better. I think the y-intercepts are easier. So I would have y equals, anywhere I see x, I'm going to replace it with a 0. So I have 0 squared plus 8 times 0 plus 7. How's that going to clean up? 7. Y equals 7. So what does my y-intercept look like then?
0, 7.
0, 7 for my y-intercept. You guys okay with that so far? All right. Let's go look at part B. For my x-intercepts, I let the y be equal to 0, so I'm going to have 0 equals negative 2 times the square root of x plus 9 minus 10. What should I do first?
Set y equals 0.
I did.
Oh, wait.
That's okay.
Sorry. Yeah.
Add 10 to both sides, okay? Because we need to isolate that radical. You have to isolate the radical before you square both sides. Otherwise, it doesn't work that way. Divide both sides by negative 2. What would that give me on the left? Negative 5 equals the square root of x plus 9. What next? Normally, that's what I'd do. Normally, I would square both sides here. Why can't I this time?
Oh, because one side has to equal 0? Wait, what? Never mind.
I like what you were talking about with one side, though.
One side has to be a variable?
One side doesn't necessarily have to be a variable. Look at both sides of this. Tell me what's wrong. One side is a square root. The other side is... Can that happen? Can I take the square root of something and get a negative answer? That's not possible. I'm only allowed to take the square root of what types of numbers?
But we're not taking the square root, are we?
We are. The square root was part of my original problem. I would be squaring both sides, but what this says right here is whatever this evaluates to, I'm going to take the square root of it, and I'm going to end up with something that's negative. That's not possible. It is not possible for a square root to equal a negative number. So if it's not possible, what's my x-intercept?
0.
Undefined?
Undefined. There isn't one. This never touches or crosses the x-axis. No x-intercept here. If I were to graph this particular one, this square root function, remember square root functions have a starting point and then they only go in one direction. This particular one is underneath the x-axis, that's that negative 10. And then because it's been reflected, it scoops down and heads out forever. It never, ever, ever gets close to the x-axis there. All right, so that one didn't have an x-intercept. Let's find our y-intercept. What do I do to find the y-intercept? Let x equal 0. This one's easier for us to evaluate, and there's no tricks here. So I have 0 equals negative 2 times the square root of 0 plus 9. Oh, thank you. It's supposed to be a y. I even did it in black to remind myself of that. Thank you. Minus 10. So 0 plus 9, that's 9. What's the square root of 9? 3. So I have negative 2 times 3 minus 10. So negative 6 minus 10 gives me what? Negative 16. So what's this ordered pair then? 0, negative 16. There's my y-intercept. Let's do one more, and then we'll shut it down for today because I want to take some questions. I was getting a lot of emails last night about the homework. I think some people had different questions, and I want to take a moment to address those. So let's do the x-intercept first. What do I let be equal to 0? Y. Let our y be equal to 0. So I have 0 equals x plus 5 over x minus 2. What would I do to get rid of the fact that this is a fraction? I could do the conjugate to get rid of things that are like square roots or i's on the bottom.
Could you just multiply them?
Yeah, we can multiply by our denominator. What's going to happen, though, when I multiply by this denominator?
Still 0 on the other side.
Still 0 on the other side. That's okay, though, because remember, my denominator can't be a 0. So I get 0 over here equals x plus 5. Subtract 5 from both sides. Where does this cross the x-axis at? X equals negative 5. So my ordered pair would be negative 5, 0. For my y-intercept, I'm going to let the x be 0. So I would have y equals, up in the numerator, I'm going to have 0 plus 5, right? Down in the denominator, it's 0 minus 2. So how's that going to simplify? Negative 5 halves. Absolutely correct. So I have y equals negative 5 halves, or you could write that as negative 2.5 if you wanted to. So 0, negative 5 halves. Beautiful. All right, 3.1 homework. Who had questions over that? Yes, sir. And you had questions as well?
Mine wouldn't open last night.
Okay. I'll see. I tried something last night with it. I don't know if it worked. I went in and manually submitted it and then reopened it to see if that would work. Try it again today. If it still doesn't work for you, just send me everything on paper and I'll attach it. I don't ever want technology problems to be the reason that you don't get credit for something. Ethan, which ones did you have questions about?
The line thing.
The line thing.
Yeah.
Here, I've got a copy of the book because I want to make sure I'm hitting the right things. Here's the 3.1 homework. Give me an example of one.
It was those.
These ones here. Oh, describing the set of all points.
Yeah, but I didn't get that. Like
Okay.
I got half of it, and I didn't understand how that.
Okay. Like the second half?
Yeah.
All right, so if I look at number 8, part D, x, y equals 0. What operation is happening between the x and the y there?
They're multiplying.
They're being multiplied. So what's the only way to get a product of 0?
I don't know.
What would have to be true if I multiply two numbers together and I get 0 as the output?
One has to be 0.
One of them has to be 0. So either x equals 0 or y equals 0. Tell me everywhere on a graph x is equal to 0. On the y-axis, right? This is all points on the y-axis. And so where is the y part of every ordered pair equal to 0? Yep. That'd be all points on the x-axis.
I don't get the one where it's like, say y is greater than 2 or something.
Okay.
I don't understand that.
So y is greater than 2. So if I think about this on a graph, what would this look like if I graphed it? What kind of a line would it be? What axis would it go through?
I don't know.
This is telling you the axis. This is telling you where. So it's going to go through the y-axis at 2. If it goes through my y-axis, which way would it have to go?
I don't give a ask.
I'm going to graph the line y equals 2.
Okay.
This is the equation of a line. It tells me the slope and the y-intercept. That's in slope-intercept form right there. What's the slope of it?
0?
0, which means a horizontal line. Y equals 2 is going to be a horizontal line that goes through the y-axis up at 0, 2. So it's going to be right here. And then if it's a greater than, which way would I shade it? Up. So if I wanted to describe all of those points, this would be all points above the line y equals 2. And I could further describe y equals 2 by saying it's parallel to the y or to the x-axis, and it goes through 0, 2 on the y-axis. Does that help?
Uh-huh.
Okay. Did anybody else have any other questions about the 3-1 homework?
I have one, but it's just about submitting.
Okay, fair enough.
So, it says I submit.